So, we discussed bond polarity. Some of bonds we consider to be polar, some of them are non-polar. But to have an idea what's about a molecular polarity, you need to pay attention to geometry of molecules. So, for to determine geometry or shape of molecule, you need to understand the concept of the electron groups. Electron groups are not just bonds, single, double, triple, but they also lone pairs. Electron groups are any group of electrons, basically. So if you have a bonding pair, that would be single, double, or triple bond, or you have non-bonding pair, which is a lone pair. But they are still electron groups. If we look at the number of atoms that is given and determine the type of the electron group, and we can do this example. So for carbon number 1, there is a 1. Yeah, there is a 1, 2, 3, and 4. Four bonds here, and you can see it, and I'm going to put this number 4 in a section number 1. Why I'm doing this? So I can repeat. So to discuss, to determine the geometry of molecule, we need to count all bonds, and we need to count all lone pairs which surrounds the atom. So now I'm going to erase this so that we can do another one for carbon number 2. We have 1, 2, and now we have 3 electron groups. Yes, you can object that there's a double bond here, but still we count these double bond as a single electron groups. So for carbon number 2 is going to be 3. We have 3 electron groups rounded carbon number 2. Okay, now the next one. It's going to be carbon number 3. And we have to look at its bonding. It has 1, 2, 3, and 4. So it has 4 electron groups, and all of them are single bonds. And I put number 4 at section number 3. So for carbon number 4, if it has 1, 2, only 2 electron groups, so 2 electron groups, and I am going to put the number 2 in for carbon number 4. So 2 electron groups around the carbon number 4. So for atom number 5, which is nitrogen, I need you to pay attention. We have 1, but then we have this lone pair that's also a group of electrons. So we have 2 for nitrogen, and for oxygen here, we have 1, 2, 3. Yes. So we have 3 for oxygen, which marked number 6. And for hydrogen, it's only 1 electron groups, which is bonding groups. How many lone pairs and how many electron groups are around a specific atom? This is what you need to pay attention. So I hope that now it makes more sense for you that determine geometry of molecule, or you need to count not only bonding electron pairs but lone pairs too. So you're just counting how many lone pairs and how many electron groups which are bonding around a specific atom. Okay. So now you can see, for example, here we can look at different shapes and different names. So if you have a central atom and there's only two electron groups around it, then this is going to be a linear shape. This is when atom has the least repulsion between electron groups, and they're not going to be like this. This is so let's say if I have carbon dioxide, carbon connected to oxygen, and you can see here this space is not used up, so instead of this it's going to spread out like this, and that minimizes the repulsion, the lone pairs on oxygen. So each oxygen has two lone pairs. It doesn't matter because this is not the central atoms. These are not central atoms. We only care about the atoms that connects all of them together. That's central. Carbon here is central because in that case the central atom must keep all of the other atoms intact, right? So only the central atom is matters if it has lone pairs. So it doesn't have lone pairs there. If the central atom doesn't have lone pairs, so it doesn't matter. It doesn't matter. You don't need to calculate lone pairs from atoms which are not central. So let's do concept checking, and I hope it will help you to understand. So the first molecule is methane. This is a gas that heats up our houses. We have methane, and then we put their hydrogens around it, and remember each hydrogen brings one electron, or carbon is central atom, and uh, hydrogens are bonded to this carbon. So carbon is a central atom. So we see that carbon has 4 bonds. So the number of electron groups around the central atom is 4. This is my central atom, and 1, 2, 3, and 4 number of lone pairs of the central atom is 0, and geometry, it look that it and the picture you can see that if you have a central atom with 4 central groups and it's bonded like here with 4 hydrogen, there are no lone pairs on the central. That's going to be tetrahedral, and in this case it's actually the shape of and the electron group geometry. So we'll see that it's not always the case. So both tetrahedral the electron group geometry and molecular shape will be the same, so tetrahedral. Now let's do the next one. It's going to be nitrogen because remember uh, it's going to be around with fluorine because the balance, the number of valence electrons for nitrogen is 5. So fluorines, they have 7. And had just one unpaired electrons and nitrogen has three. Remember that no one paired electron should remain, or all electrons should be paired. So we have one, two, and then we have three right here. Oh wow.